Hello. My name is Antonio. I'm not from Red Hat. I'm a consultant. I'm a freelance.
And my name is Arun Gupta. I am from Red Hat.
You see the difference? The Red Hat?
Well, you have hair. I don't.
Okay, so here we are. We have 50 minutes to talk to you about Java EE 7. So we thought if you know Java EE, in 50 minutes we can show you 50 new things of Java EE 7. So it's going to go a bit fast, 1 minute per new feature. Ready? So here is the Java EE landscape. Some boxes, specifications with numbers. Some boxes have a 1.0 version, like badge, so that's brand new in Java EE 7. And most of them have been updated. So we're going to talk about the new specs and the new things within the already existing specs, okay? So we will start from left to right, from the common ground things, and then we will go up the Java EE stack. Let's go. CDI 1.1. Remember, we went from CDI 1.0 in Java EE 6, revision in Java EE 7. Unfortunately, not many new things within CDI. You will see that during the presentation, CDI has been put in other specifications, and we will talk about it throughout the entire slide deck. But CDI itself hasn't been that much updated. Feature number 1, for those of you who are fed up of having empty bins XML, because if you don't have a bins XML file in your class path, it just doesn't work. In 1.1, the bins XML has become optional. So if your bins have an annotation, application scope, session scope, named, they are automatically detected by CDI. If you want the good old feature of 1.0, well, just put a bins XML in your class path. And then you can play with the bin discovery mode. You can say, discover all the bins, discover just the annotated bins, or none. So that's something new in 1.1. And if you say discover all, there's one new thing in 1.1 is you can veto. You can say discover all the bins except this one. So you have this new annotation called vetoed. But you can also do that in a package. Very, very handy if you have your entities, all your entities in a package, and you can say, I veto the entire package. So that optimizes the bin discovery mode of CDI. That's all for CDI 1.1. Let's move on to bin validation. Again, we go from 1.0 in Java EE 6 to 1.1. And this time, there's not many new features, but a killing one. You know, I really like this one. Until now, in bin validation 1.0, we could put constraints on attributes and classes. Now, we can do that in parameters, method and constructors parameters, and also return types. So here, as you can see, in the constructor itself, the card validator, the algorithm mustn't be null. So we put the @not null within the constructor, and the method below, we have the same thing on the parameter, the method parameter, but also the return type. So we said, when you leave this method, make sure that the return type value is true. And bin validation was able to do that in constructors because the interceptor specification got also updated. For those of you who follow the history of Java EE, interceptors were in the EJB. Then the specification got out in Java EE 6. So we had the EJB 3.1 and the interceptor 1.1. So now we updated the interceptor specification. What did we do? Well, now we can intercept constructors. That's, been validation brought this new concept to the interceptors. So we can still do an around invoke, the good old around invoke. But now we can also do an around construct. So we can intercept the constructor call and do some business logic before and after the constructor is invoked. And our interceptors work nicely with CDI, with interceptor bindings. Well, there was one missing point in CDI 1.1 was when you have interceptor bindings, how do you organize them? How do you say, use this interceptor first and this one second and this one third? You couldn't do that with interceptors binding in CDI. So the interceptor spec was updated to have this new annotation called priority. So I give a number to an interceptor, and then the container computes all the priorities and goes, well, this one is first, this one is second, and this one is last.
All right. Concurrency is 1.0. So this is, as Antonio said, 1.0 means it's a brand new addition to the platform. The main principle behind concurrency is in JDK, we already have JDK util concurrent package that gives you all the abilities, like how can I run my executor service? How can I run my schedule executor? So the concurrency utilities, which is JSR 236, gives you a managed version of that. And what that means is now you can spin up user threads, but they're going to be managed by the container. Okay? So the biggest advantage to you is you can still continue to spin up threads, get managed by the container, and your class context, your JNDI context, your security context, which otherwise is not available in those threads, is now available in those threads. So if you take a look at it, we now have a managed executor, for example, managed executor service rather. And I can easily inject it using add resource. I say add resource, I inject the managed executor, or I can do simple JNDI lookup. I can say, give me the JND name. It looks up the managed executor, gives you the managed executor. Now there is a default managed executor that is available for you, which you can always inject or get a handle to. But if you want, you can also put it in a web XML. Say my application needs multiple managed executor, and on each managed executor, I want to define certain properties. What is the time to live for a thread? What does the pool look like, etc. Now those properties are not standard, but at least you have the ability to define multiple managed executors in your web XML now.
Arun.
All right. That's called as managed executor. So we also have a managed schedule executor. So there is a schedule executor in JDK, once again, Java util concurrent package. Now with the managed schedule executor, you're getting a managed version of it. And this allows you to execute tasks at a certain interval. So execute the first task after 2 seconds, every task, and the next task every 3 seconds. So very standard JDK design principles, but now being applicable in the Java EE layer. So just like our managed executor service, we can do it, we can do the injection using add resource, we can do JNDI lookup, or we can define it in web XML. So both very similar designs, but all the methods that are available in JDK are now applicable in Java EE as well. So here is an example. I can say, once I get an executor, I want to execute a task after 2 seconds, and then after that, I'm saying schedule at fixed rate, run the next task after every 3 seconds. So if you recognize, these APIs are from JDK itself. All I'm doing different is these threads are now managed by my container. Just like thread factory in JDK, we have a managed thread factory. So this managed thread factory allows me to spin up new threads. These are not executors, but these are single threads here. So you can spin up single threads. So, or I can do a context lookup. So the design principles are very simple. You can inject the executor objects or the managed objects in concurrency, or you can do a JNDI lookup, and for each one of those, we have a corresponding default object, or you can define them in the web XML as well. The fourth object that is introduced in JSR 236 is dynamic proxy. So now, let's say those objects that were defined previously are not really meeting your needs, you want to assign a context to a random POJO object. I just want to have my context available over there. So in that case, what you do is you create a dynamic proxy. I'm going to inject a context proxy. I'm going to get my contextual proxy from the context service. I'm going to create a contextual proxy. And to the contextual proxy, I'm going to assign it that, okay, you know what, this is the object where I want to have all the context available. So you can literally assign that context or pass that context to any random object. And in that random object, you can start doing JNDI lookup as if you were in the container itself.
Now let's go up the business stack. JPA 2.1. Well, that's quite a nice update. Many different things. The first one is we finally get standard and portable properties to generate a schema. So as you can see here, the first line goes javax.persistence. So that's the portable properties in JPA. Schema generation, script, and also database. So you can ask JPA to generate your DDL scripts, but also to generate your memory. Things that, Hibernate and Eclipse Links were doing anyway. So now it's standard. You can even load scripts. So here you have the SQL load script source. You give the name of the file, and at startup, JPA executes this file. Again, something common with Hibernate. The file used to be called imports.sql, and Hibernate will automatically swallow this file and execute it. Now you can do that in a portable way. And there's also an API. So here I'm just showing the properties. But behind, there's a new API where you get your entity manager factory, and you go entity manager factory dot generate schema. So with Java, with an API, you can generate your DDL or in-memory database schema. So that's nice. So if we can generate our schemas, let's go a little bit further. So that's something that our DBAs will love, is within our code, we can create indexes. We can say, in the book entity, I want to create an index on the ISBN number and the number of pages. So when you generate your schema, either using an API or a deployment with the properties, JPA will create your indexes. Something new, not sure that the DBAs will like that a lot, but now as developers can have an impact on indexes. Until now, in Java EE, we had two kinds of entity managers. We have the default was the persistence context life cycle was attached to the transaction. So if you don't save anything, you just go add persistence context. The default was the life cycle of my persistence context is attached to the transaction. And we also have the extended mode. So you go persistence context dot extended. So meaning the persistence context is much longer than a transaction. Now in JPA 2.1, we can unsynchronize it. So basically, he lives on his own, and you decide when the persistence context join the transaction or not using the entity manager dot join transaction method. Something that maybe most of you were waiting for, a nice way to call stored procedures. We like it or not, but our relational database, most of them have stored procedures, and to invoke them, it was a bit, tricky and non-portable. So now we have a brand new API, the @named query, @named native queries. Now we have a @name store procedure query, and we give the parameters in, out, the name of the stop the procedure and invoke it. And there's also other things. You know, we didn't have a lot of, we only have 50 slides, but there's also in JPA 2.1, we can create graphs. And we can say, we can define a graph of objects and tell the query, instead of bringing everything, I just want you to bring this graph, you know, a subset of your entities. So graphs are also new in JPA 2.1. Well, going with a transaction, JTA 1.2. Do you know how old was JTA 1.1? I think it was 2001. The specification hadn't been updated for 12 or 13 years. So it was time to, you know, do something fresher. Well, we took the good old container management in EJB, the transaction container management, and basically took the idea out of EJBs and brought it back to where it should have belonged to JTA. You know, with an EJB, with just one annotation, the transaction is managed by the container, where you go at stateless. That's the same idea, at transactional, except you can do that anywhere now. So in Java EE7, you can have a transactional EJB, but also a transactional servlet, a transactional REST endpoint, or a transactional POJO. So you just take a POJO, put a transactional, and bang, it becomes transactional. And as you can see, the exception handling is much nicer, because you say, you know, again, we kept all the good things from the EJB, so we have the 6 modes, you know, the required new, support, and blah, blah, blah. But the exception handling is much nicer. You go roll back if you have an SQL exception, and don't roll back if you have a SQL warning. So in this aspect, it's much nicer. And you know what the transactional is? It's a CDI interceptor. A transactional is a CDI interceptor binding. So I was telling you that there's not much new things in CDI 1.1, except it went through different specifications. JTA now needs CDI when it comes to the transactional. And something else that, you know, uses the CDI is there's a transaction scope, actually. So in JTA, there's a scope where bin's life cycle depends on the transaction. And again, that's created using the CDI scopes. EJB 3.2, nothing much, you know. If you have a stateful EJB, you can say, don't passivate it, okay? And the @asynchronous annotation that existed in the EJB now can be used in the EJB Lite. So nothing too exciting in the EJB landscape. The most exciting thing was taking the transaction management and putting it back in JTA. JMS, it's one of those specs like JTA that wasn't updated for years and years and years. I think JMS 1.1 again was 12 years old. So the idea was JMS was 12 years old because it works. It's this kind of API that does the job, except it was a little bit verbose. You know, to send a message, you needed 10 lines of code, and same thing to receive a message. So, you know, I suppose the underlying engine doesn't change, but the API does. So this is how you can send and consume a message. Everything starts with this new API called JMS Context. And as you can see, we use the good old connection factory, except the connection factory now has a new method called create context. It gives you a JMS context, and with this context, you go .create producer, .send a message to a queue, and that's it. To receive a message, well, you take the same context and you go dot create consumer, giving a queue, dot receive body, and it's a string, and that's it. And this kind of Fluent API can be used for several things. You can go dot create a producer who's going to produce a message of priority 2. The message will have a time to live of 1,000. The delivery mode will be non-persistent. Bang, set the message to the queue in one line of code. So that's nice. Java E7 is built on top of Java SE 7. So there's also something nice about this API is it implements the auto-closable. So as you can see on the top line there, we have a try resource block. So we go connection factory dot create context. We put that in a try block, and at the end, the language will invoke the close method because it implements auto-closable. So again, it makes it very neat and short in terms of lines of code to send and receive messages. For those of you who have followed closely Java E6, there was this new idea of, with an annotation, I deploy a bit of Java code and it creates a data source. So there was this annotation called @dataSource definition. The same thing happens with a JMS factory. So we have this new annotation. You put it on a bin, and when you deploy this bin, it creates a connection factory. So you don't have to go to your admin console and create a factory. You can also do that with an API. Same thing for destination. So if you want to create a topic or a queue, you can either do that in your admin console or just with code. So that makes it nicer to bootstrap, application in different servers. Servlets now.
All right, so as servlet, typically with Java EE, the design pattern is like in one particular version of Java EE, you will have a .0 version, which is sort of a major revision, and then the next one will likely see a .1 version or .2 version, kind of a minor revision. So servlet was a major revision in Java EE 6, so Java EE 7 sort of saw a minor revision of it. 3.1. So in servlet, typically if you are in a do-get method and if you want to receive the input from a client, it's a blocking thread in the sense, if you look at it, I'm reading in the red part of the text, I'm saying, okay, give me the input and I'm going to keep reading till you do -1. That -1 could be for several reasons, the timeout or connection client actually stops sending the data or something happened on the network and then you get an error or things like that. But your thread on the server side is essentially blocked. So how we fix that? In servlet, basically we added this concept of non-blocking I/O. So it's a very standard design pattern in terms of suspend and resume, but effectively on my servlet input and output stream, we added a read interface and a write interface. So I could create a read listener and a write listener, and I can set it on my stream. So on my read listener, for example, now I have methods available which says on data available. That means anytime there is data available, call this method. Okay, on data available, I'm going to read. In the implementation of on data available is where you're going to read the method, read the data, and when everything is read, then you can say I'm done and return back. Similarly, on write listener, you can say on write possible, and then you write it. So this way, your thread is not blocked. You're parking the thread so that it could be used for something else, and when there is data available to read or write, you actually do the read and write. This only works on asynchronous servlets because that's where you can actually suspend the thread and resume it. Otherwise, it's anyway blocking on the server side. So you just simply set the listener or read listener or write listener. We'll talk about WebSockets in a little bit later, but essentially the way WebSockets work is you take an existing HTTP connection, and HTTP RFC defines how you can upgrade it to a non-HTTP protocol. That's a standard feature of HTTP. It originally was designed so that you can take HTTP 1.1 to maybe 2.0 upgrade. But that's how WebSocket is leveraging that feature and saying, we can upgrade from HTTP to WebSocket. Now, yes, WebSocket is leveraging it, but the way it's implemented is using Servlet 3.1. So Servlet 3.1 provides kind of a HTTP abstraction in Java EE. So you can say, I want to upgrade to my own web protocol, for example. So there is an upgrade handler, and the web upgrade handler gives you a web connection. And in sense that the web connection gives you really just the servlet input and output stream. So you define exactly what your protocol is going to look like, what's on the wire format is going to look like. And that's what effectively WebSocket is. You just get a raw input and output stream. So like in Wildfly, we are implementing web connection, which is saying this is my WebSocket connection handler, and which is doing all the WebSocket in and out. In Servlet, if you look at this code fragment, if you have a servlet defined, and if everything is unprotected, or everything is, let's say, in a web XML, if you have one method protected, say HTTP GET method is protected, so you're defining your authorization constraint, and only GET is protected. By default, GET, put, post, delete, and other verbs are automatically unprotected. So those are called as non-protected methods, basically. And that's a potential risk, because, hey, I just want to protect GET. Why don't you protect the others for me as well? But just to keep backwards compatibility, Servlet 3.1 added this element called as deny uncovered HTTP methods. What that means is, so I'm covering GET, but what that means, everything else that is uncovered, you automatically restrict them. That means you need to explicitly poke a hole in web.xml if you want to protect them or explicitly or expose them somehow. Moving on in WebSocket, as you can see, WebSocket is 1.0, so that's a brand new addition to the Java EE platform. And this, in my opinion, was the one that was most talked about, has the most interesting ramifications in terms of how the platform is going to evolve. So WebSocket, in one line, if I want to explain it, is full duplex bi-directional communication channel over a single TCP. HTTP, by nature, is half duplex, in the sense, at a given time, client can talk to server, or server can talk to client. WebSocket, by nature, is full duplex. Both client and server can talk to each other at the same time. There is no standard request-response design pattern. So that's the important part. It's bi-directional, because both client can talk to server, and server can talk to client, which is, again, unlike HTTP, because it is always client-initiated. And the best part about WebSocket is it's over a single TCP connection. So like in a typical HTTP request-response, you send a request, you get a response back, and typically your TCP connection goes away. There is pipelining and all those things, but your application cannot really rely upon that. That's more like infrastructural things. So that's where exactly WebSocket fit in there. It says, I'm going to take an existing HTTP connection on a TCP connection, upgrade it, and once it becomes WebSocket, the TCP connection is going to stay open. That's what makes the fancy about WebSocket. How do we do a simple or a canonical chat server, for example, for WebSocket? That's the most simplest or dumb example, so to say, for WebSocket. Well, on a POJO, you put a single annotation called as @server_endpoint, and that's about it. No deployment descriptor, nothing, just single annotation on the POJO makes it a WebSocket endpoint. Now, a WebSocket can receive text data or binary data. So if you want to understand which business method to dispatch, if I'm receiving a text data, on that business method, you put the @onMessage annotation. Well, the moment you put the @onMessage annotation, you got to identify the parameter that's going to take my text payload or binary payload. So you put a string parameter over there, or byte buffer, or byte array. So very simplistic programming model, but once you understand the basics, it just literally works out of the box. So like we have onMessage, which says whenever you receive a payload, call this business method. There are also lifecycle callback methods. So whenever a client is connecting to a server, I want to call a business method. I want to have some state over there. Or whenever a client is disconnecting, I want to call a business method. Or if a client is sending me a message and there is a stack trace somewhere in the entire flow, give me the throwable clause over there so that I can play around with it and figure out what's wrong with it. So those are all my lifecycle callbacks method. The typical way WebSockets work is, you have a WebSocket server endpoint at the center, and think of it as a wheel. All the clients are at the edge of the wheel. So you have your server endpoint we talked about, but you can also have a client endpoint, because essentially that client is also listening from messages from the server. But remember, there is no URI here, because not other clients can't connect to it. So because of a wheel model, if a client want to talk to another client, it has to go through server. But you still need to have the concept of a client endpoint. And the way we do that is, once again, take my Pojo. On the Pojo, I put the add client endpoint annotation, and you have your standard lifecycle callbacks, as in the case of server endpoint. Most of the time, your annotated endpoint would work out of the box because it's simple, easy to use, easy to get started. But let's say you need more knobs and dials, that I want to control how my connection negotiation is happening, what headers are coming back and forth, how the whole payload is being exchanged. That's where you get into your programmatic endpoint, which is the next slide here. So what I do in this case is, I'm saying my chat server is now going to extend the endpoint. And because I'm extending the endpoint, now I can actually override the onOpen method. So not only I get session, which is sort of encapsulating the client to server conversation, but I also have an endpoint config, which is basically saying this is how I can configure my endpoint. Okay? Now here, it's of course by design is verbose because it's giving you more knobs and dials. But you can say I want to set up my message handler that's handling some text messages here, and you can specify whether you want to handle the whole message or asynchronously or partial message. In the case of programmatic endpoints, if you look back here, there is no way to specify the URI. So then you have to explicitly implement the class, which is server or interface, server application config. And so the Java EE 7 runtime automatically reads your WAR file, looks for the classes that are implementing that interface, and then figure out, okay, I'm going to load the configuration from that. And here you're saying, okay, this is my endpoint, this is the URI where it's listening, and this is my configuration class. So a little bit more verbose, but by design. My config, in that sense, is extending your server endpoint configurator. Here you can start modifying handshake. You can even start specifying how many instances need to serve the client endpoint. So by default in WebSocket, even though it's at the center, but for each client, a new instance of server is being created. So you want to say, no, I want to have a single instance. So you update this method, get endpoint instance, and it'll start returning a single instance of the endpoint, which is serving all the clients around the edge. Now, typically, if you're receiving text and binary data, so you might be receiving JSON data, but you may not want to process the JSON data as is. You say, I don't want to spoil or clutter my business logic. I want to deal with raw POJOs, or I want to deal with actual business domain POJOs. So in which case, what you do is you take your JSON, and you have some logic which allows you to convert that JSON into your POJO. But you don't want to put that logic as part of your WebSocket endpoint itself. And that's the concept that what is showing here. So for example, I could say, I have my encoders and decoders class, which knows how to take the text or binary and convert it into my business domain objects and vice versa. So I'm using my dry principle, don't repeat yourself. I'm putting all that code which knows how to encode and decode into my encoders and decoder classes, and then specifying them in my server endpoint. So here, for example, I'm saying, this is my decoder, this is my encoder, and instead of saying string, I'm just dealing with my business domain object, which is chat message. Potentially, what I'm doing is, my decoder is saying I'm implementing decoder.text, and then I know how to decode chat message. And if it's taking a string payload and returning my binary object, which is right back here. Similarly, in my encoder, I will say I'm going to encoder.text, and I'm encoding a chat message to string. Because essentially, on the wire, what goes is text or binary. So you still have to do that conversion. EL 3.0 for people who just follow the history of Java EE. Expression languages has always been part of Java EE, but it's more like JSP, part of JSP. Now expression languages is extracted and put it in its own specification, and that's EL 3.0. And the advantage of that is now you can use all the good functionality that EL 3.0 provide in a standalone application very easily. So for example, let's say I want to write my own configuration file where I want to understand if you're putting any expression language over there, I want to bind it to my beans. I want to evaluate that and implement that business logic in my configuration data, for example. So what I'm going to do is I'm going to use EL processor. So as you can see in the code here, I can spin up a new EL processor. I can start resolving the beans the way I want to resolve the beans, or what that really means to me. One of the classic examples of this is how this is being leveraged in batch processing. So in batch processing, which we'll talk about shortly, is you need to have a job XML. You need to define your job as a job specification language. And in that specification language, you need to specify what beans are being resolved to. That's where this EL processor is being used and becomes very handy. That's your favorite topic?
No, that's yours. I'm not a web guy. You do it.
JSF is Java Server Faces. It's a pretty mature technology as such, I would say. It's been used for many years. So the 2.2 kind of gives you an indication that it's a minor release in that sense. Now, with JSF 2.0, we made good additions where we said, oh, we're going to use just XHTML and CSS or facelets for templating. So that gave me kind of a true MVC architecture because I can just have my views purely in XHTML and CSS. Model and controller are sitting in my backing beans, JPA, EJB, CDI, whatever that is in the background. But what was missing from JSF was, if I want to create a flow, so like a shopping cart flow, where I have a page, another page, another page, they work in a proper sequence, and I want them to look and feel exactly the same, and I want them to behave similarly, so that if I can give it to somebody else, here you go, take my jar file, here is my shopping cart jar or flow, and you can embed into your application. That was the missing piece. And that's what this is talking about. So for example, now if I have in my Maven app, I could have a flow1 directory, and I can say, oh, I want a new flow, and this is sort of my entry point to the flow. So whatever flow1 is, you give the same name here, that becomes your entry point. And then as you keep clicking around, you can see what is the exit point, and that just works. Or you can say, I don't want to name the directory and the entry point page same. Then in this case, you can say, I'm going to have a flow2-flow.xml. You define a flow, and then you can declaratively start defining how your entry points and exit points of the flow look like. And then rest of the pages, of course, they just bundle along. So now with this, you can package all of this in a jar file, including the backing beans, and give it to anybody. So this is a packaged, reusable flow in a jar file. There is a flow scope. That's, again, a new CDI scope, so you can start saving flow scope data in the bean. You can also do the flow definition, how your flows look like programmatically, so not just declaratively, by the way. And there are EL expressions as well. So for example, in a JSF page, you can say whether I'm in a flow scope or not, or give me my flow scope data, so you can start saving and retrieving the data that way. Another thing missing from JSF 2.0 in general was resource library contract. So you want to give a consistent look and feel to your web application. So you've designed your CSS, you've designed your XHTML, you've designed your templates. I want a top header, I want a left bar. Oh, flash. You design your template, and then, but you eventually start copying that code. So now what you can do is, here in my web XML, for example, I'm just having a jar file here, and in the jar file, essentially, I've said, oh, this is where all my contracts are going to look like. In my web pages, I can just refer to the contracts read, and if I refer to it, and that will work for me. So the advantage of this is, this jar file could then now be copied into your application server library, and all the WAR files can start referring to it. Another new feature added to JSF is pass-through attributes. So here, if you look at it, HTML5 added this type attributes. So I'm saying type equals email, but if you give it to JSF, the way it's going to render it, it says, oh, you know what? I don't understand this type email because there is no corresponding UI component to it or HTML render kit, which knows how to generate the HTML code for it. So I'm just going to generate type equals text. That kind of defeats the purpose of being HTML5. So now what you can do is you can say, oh, I can have P:, P being just a random prefix specifying to pass-through namespace. You say this is in the pass-through namespace. Just pass it along as it is to the render agent or to the generated HTML, and let the render agent define how it's going to generate the corresponding HTML. So it's just generate type equals email for you. And finally, something to be excited about, JSF has a file upload component. Works very well with Servlet 3.1 multi-part file upload.
Well, JSF had get support in Java E6 in 2009. So
right.
Well, we have file upload now. JAX-RS 2.0. One missing feature in 1.1 was the client API. JAX-RS 1.1 was about standardizing the way you expose a service, but now how you consume it. Again, taking back the same builder API idea that we saw in JMS, we do the same in JAX-RS. So here you go, client builder, give me a client, and then with the client you say, well, I want to target this URL. So that gives you a web target. With this web target, you go, I want to do a request text plain or XML or JSON, and I'm going to build a GET that's going to return an invocation. Once I have the invocation, I go invoke, and that gives me a response. And on the response, I can see if it's a 4, 200, or 201. And the good thing is you can write exactly the same thing with one line of code. So you can go client builder dot new client dot target this URI dot requests a MIME type dot get, and that returns a response. Or if you're just interested in the body, you can write the same thing, and as you can see at the bottom line, instead of just doing get, I'm saying get, and by the way, I want to get it as a string. So instead of returning a response, it gives you the body. It gives you the entity of the JAX-RS client invocation. So, you know, something new and neat. Asynchrony. Now you can have a synchronous call within the client and the server. So the way we do that is we use the same API, as you can see, .new client .target .request, and we have this async method. So we're saying we want to do a get, but asynchronously. And as you can see, it returns a future. And then I do a future get, the get being blocking. So that's on the client side, but you can also do something like that on the server. So in the server, you can say, I suspend the response, and as you can see, we start a new thread, do some business logic, and resume this asynchronous response. So asynchronous client call, but also server invocation. Something new in JAX-RS 2 is, well, I'm going to add filters either on the client or on the server, and it can either be on the request or on the response. So I just want to intercept on both ends either the request or the response. We have new APIs, so the client request filter, so the client request, client response, or container request and container response. And the way we use it is you just implement it. So here I implement the client request filter. So I am on the client side, and I want to filter the request coming. And I implement the filter method. As you can see, I have the client request context, a bit like interceptors who have invocation context, so the same idea. So that's for the request either coming or, request or response. But there's also, you can intercept the body, the body of the request. So here, again, I can either intercept the body when I read it or when I write it. Two interfaces, again, the reader interceptor and writer interceptor. And the way to do it is I implement the method around write to, so I'm saying I'm going to write the body of the request, and I intercept it, and I'm going to zip it. So here, it's like an interceptor, but for JAX-RS. JSON-P, we're running out of time.
We can cover it in about a minute.
Yeah, JSON-P, it's easy. JSON processing. So for those of you who have followed, in XML, we have the JAX-B for binding, the JAX-P for processing. Now we have the JSON-P P, maybe JSON-B will come in Java E8. So the idea is how programmatically with an API I create JSON objects. So as you can see, I go JSON create object builder, add all these nodes, and at the end I can build either a JSON stream, a JSON string, so something like that. And another very low level API when you can pass JSON with events like in JAX-P, the same idea, except the API is slightly nicer.
All right. So batch processing, I won't get into the details of what batch processing is, but basically in batch what you can do is you can take an item-oriented processing. You can take an item, and I'm going to say I receive a CSV file with thousands of lines in there. My item is one line. I'm going to read an item. I'm going to process / validate it, and I'm going to write it. Writing could be maybe to a data store or to another queue or something like that. So what I do is I define my job as an XML file. It's called as job XML. Item-oriented processing is also called as chunk-style processing in batch. So I can say, I have a reader. The reader is going to read from a JPA, any source, CSV, REST endpoint, stream, name it. Then I have a processor, which is going to take that object that is just being read and validate it. And finally, I have a writer that's going to say, oh, I'm going to write it out now. But it doesn't, for every read, it doesn't write out. It says, I'm going to read it, validate it, and aggregate it. So you define how many items need to be read and aggregated, and then it write it out in a chunk. So for in a database, that's a lot more effective way to do it. Or you can do an ad hoc task. Like one task is just upload a file or send an email, and you can schedule that as a batch job as well. For different stages of batch, there are listeners. So like there is a job has a step, there could be multiple flows, and there could be readers, processors, listeners. So there could be a reader, processor, and writer. So that means there could be listeners at each of those stages, before and after. So there's provision for that in the job XML. And each of those could be implemented as interfaces and convenience abstract classes. Abstract classes are basically implementing the interface and giving you simple methods that you can override. So here is an example. I'm extending the abstract job listener, before job and after job, so I can do setup of the resources or cleanup of the resources in either of those methods. Batch also allows you to declaratively split up across your multiple cores, for example. So here, let's say I receive my CSV file, which has thousands of records, and I want to split it up across multiple cores. So I'm saying I'm going to pass two properties, start and end, and this is coming from partition plan start and end. Now in the job XML, I'm defining partition, saying there are two partitions, partition 0, start and end value, and similarly start and end value. They differ in numbers. So at the runtime, it's going to take a reader, it's going to get the start and end value. So of, say, 1 million records, one core could process my very first 500,000, the second core could process the second 500,000. That way you can split up the load very easily. Batch also allows you to create workflows. So you can start saying, I want a flow, and all the elements in the flow, or all the steps within a flow, I want them to execute, after which they go to the next flow. So you can start sort of defining sort of workflows within your batch XML, not fully extensive, but somewhat. You can also start splitting flows to run concurrently. That I want these two flows to run concurrently. So you just say split, and then you can say after the splits, after the two flows are executed, then this is the next task that I want you to execute. The workflows can also be created programmatically. So let's say you don't have the idea or understanding of how your deployment environment is going to look like. Then you start creating the flows declaratively or programmatically in this case. Java Mail.
No, it's old-fashioned. We send tweets today. We just
Yeah. Well, let's not talk about Java Mail then.
JC.
Well, the big difference being one of the main focus of Java E7 in general, like Java Mail, JCA, new JMS destination definition annotations is, we want to get rid of the deployment script. You put those annotations right in your code itself, you deploy the WAR file, and the Java E7 compliant runtime container will automatically understand it and do the real resource deployment for you. And that's what is the theme for Java connector architecture as well. If you're building a Java E7 application, most likely you need a database. So we have a default data source for you now. You can inject it or don't even specify the name, and it defaults to that. Similarly, there's a default connection factory. We also have default concurrency objects. Last but not the least, we both are authors. If you want to learn more about Java E7, our last tip is buy our books.
And a couple of them, because we don't earn a lot of money. So if you buy, each of you buy 10, that would be nice.
All right, thank you.
Thanks.